The graph of the function f of x is shown below for values of x between -3 and 3. The areas enclosed between the graph, the x-axis and the lines x equals -3 and x equals 3 are marked in the appropriate regions. We want to determine the value of the integral from -2 to 3 of f of x. So that's going from here to here. And we can do that with the areas. Remember, anything below is going to be negative. So this one here would be -4. Then we need to include this region, which is +4. And then this one, which will be, again, negative because it's below the axis. So this should give us -2. The area enclosed between the graph of f of x and the x-axis from -2 to 3. So here we're going to not worry about the signs because the area itself is actually 4. The only reason we counted it as negative is because it was below the x-axis. So that's going to be, so going from -2 through to 3, that's going to be 4 plus 4 plus 2, which gives us 10 square units. We now want the value of the integral from 0 to 3 of f of -x dx. This transformation here, f of -x, is a reflection in the y-axis. So actually this is the same as doing the integral from -3 to 0 of f of x dx. And that's going to be 3 take away 4, which is -1. We now want the value of the integral from 0 to 2 of x take away f of x dx. We can split the integral into 0 to 2 of x dx, take away the integral from 0 to 2 of f of x dx. So this is going to be x squared over 2 to be evaluated from 0 to 2, and f of x from 0 to 2 we can see is 4. So that's going to be 4 over 2, so that's 2, and then put 0 in and get 0. 2 take away 4, so that gives us -2. Finally, we want the value of the integral from -1 to 1 of f dashed of x. If we integrate f dashed of x, we must get f of x. So that's f of x to be evaluated from -1 to 1. So that's going to give me f of 1 take away f of -1. Now f of 1, I can see from here, is 3. And f of -1 is -3. So that's going to give me 6.